right. So I was asked by Alex and Yogi, thanks a lot, by the way, to kind of talk about how we provision systems at TACC because we're not using OpenCHAMI. We're using an in-house tool. And the idea behind Horizon is like, hey, let's see what else is out there because if there's something better, why not use a better tool for the job versus just saying, well, this is the way we've always done that. So that's what my talk's going to focus on. And yeah, we'll go from there. Just quick discussion topics you can see right there for the bullet points. Just a little bit about myself, the tools, and then obviously pros and cons, and yeah. So a little about me. I joined TACC in October of 2022 after spending some time at USF, which is University of South Florida. That's where I got my HPC experience. I joined them in November 2011. So yeah, you guys can see a gray beard most likely. So I've been doing it for a bit. It's great work. I can say about when I joined HPC, it was like being a kid in a candy store. Just all the equipment, all the new stuff. To me, it felt like raw systems administration. And prior to that, I worked for various hosting companies. So supporting websites, answering a phone, people complaining because their email didn't work or their site got hacked. Lots of fun, not really. Professional interests, I really like the PGP ecosystem. And lately, I've been working on familiarizing myself with the Sequoia PGP project. It's pretty cool. It's basically like a wrapper around the GNU PGP tool, much easier to use, makes more sense. And I also like not cool programming languages, awk, Perl, Bash. With the online community, with how fast trends move, there's a lot of haters out there. I'm sorry, I feel that if it's a tried and true method, it's simple, gets the job done, I'm going to use it. And firewalls. I like the way those work. So anyway. So the system deployment process at TACC, I may make some mistakes here just because I don't feel I've been here as long as some of our other staff. But what I think is interesting is when a system gets deployed, the first thing that happens is that we'll go ahead and make sure that the rack is not part of the row. Everything gets physically put into the rack, cables attached, basically to the point where all that has to happen is we push the rack into its place in the row, uplinks get attached, and then the system gets handed over to the admins to go ahead and begin that provisioning process. And what's kind of important is that this team will actually get the MAC addresses for us, things that we need to provision the system. So they basically like, here's a silver platter, take it over. So the deployment process, obviously we have to install the operating system. It's a tale as old as time itself. So once we have a MAC address, that's basically what we would need to, at a bare minimum, get something going. We also will then associate that MAC address with an IP address and assign a system name to it. So again, this is pretty standard stuff, nothing different, from other sites. We do know the IP addresses in advance because that is given to us by our network administration. So we know what VLANs we're going to be using. We're aware of our subnet size, so on and so forth. Now, the only thing that is a little bit different is that we may initially boot the first system just to, through a USB key, just to kind of get an idea of what we're going to be going through. And also to get that generic, Ancon to kickstart config file that we can then customize and push out for the other systems when we boot them. All right, and then for the clustering integration, part of the process is knowing what kind of role this node is going to be. Will it be infrastructure, like let's say a login node? Is it going to be a compute node? Is it going to be a specialty compute node? Again, this is all stuff that when you're deploying a cluster, you kind of know what the machines are going to do. And of course, depending on the role, that depends on what packages will get installed. Will there be additional NICs configured? Will there be firewalls, so on and so forth? Yeah. Post-provisioning. This is where the configuration really gets finalized. This is where, let's say I mentioned, additional NICs. If it's a login node, it might have an internal interface and an external interface. So we configure that by hand. It could be done through an Anaconda config file, when it's kickstarted, but we do it by hand. At least I do. Is it going to be added to Slurm? Things like that. Now, one of the coolest things here that I learned from Tommy was our RCS script. And what's important about the RCS script is like this is kind of like it stands for restore compute service, basically, or return compute service, however you want to look at it. But this script will sit there and basically do all the checks necessary to make sure that node is ready to accept jobs and do what it needs to do. So it could be, do we have the latest, RPMs? Do we have the latest, access.conf changes? Do we have the latest configuration file updates? Because these are sometimes some of the things that you may forget when you're provisioning a node. To give you an example, initially when Vista was deployed, we had the notion of a 4K standard kernel and a 64K kernel. And so my RCS script would sit there and look at the node based upon its name and its role and go, oh, well, if this is supposed to be a 64K node, we need to make sure some of these other changes are made, whether it's to set, whether setting different things in the HCA through MLX config, or if we need to get additional packages downloaded. Think of it like your final check. So anything and everything that needs to be present and operational by the time a node's running, we put in the RCS. Great thing to do. Okay, so yes, please.
Is more than just an update. Are you ready to repeat this? You want a mic over there?
Oh, yeah, thanks. Yeah.
So the restart compute script basically was a tool that we wrote. It's not just to update all the software and ensure all the configuration files and everything on the nodes. It's also to test performance.
Oh, that's true. I forgot.
PCI bandwidth test to make sure you got all 4 lanes on your InfiniBand fabric. It's not just a script for software, but a very important part from our point of view for HPC systems is ensuring the node is actually healthy to run jobs. We've run into things where you have one PCI lane is down, so you're not getting your full bandwidth out of your InfiniBand card, or it's running at the wrong speed. It's not that whatever.
Well, it's funny you mentioned that because we do have all those checks in there. Memory tests.
Now, this is the beauty of the script is it's got all these lessons learned, even going back to Ranger, and we just keep them in there, and then we'll just comment them out if they're not appropriate, or we'll add new checks that look for the similar things. So it's kind of an institutional knowledge buildup as well. We're happy to share these. I mean, this is not public. I mean, these are public knowledge. We're happy to share everything we do here, but these are kind of things that we've seen on systems over time, and they cause problems. And we had problems with our Knights Landing nodes where the performance would degrade over time. So we would want to go check the performance on them to ensure they're. And then sometimes you just have to reboot them, or you have to compact your memory space. And yeah, there's all kinds of problems with that kind of thing. So the idea of this script is it's not just provisioning. It does check the health of the node. It checks, firmware versions. This is where we do a lot of our firmware version checks and everything too, not necessarily in the provisioning.
Well, like also the misbehaving HCAs where the width is reported at half speed. Yeah.
Right. So anyway, so these are things like as we stumble across failure modes, we'll then add them into this script, and then we just check them automatically. Big philosophy here is we don't want to manually have to do a lot of stuff. Automate everything, script it. Make sure you develop checks, make it easy. You can run across the board on all 8,000 nodes on Frontera and not have to worry about it. So,
another important part too is once that RCX is checked, it'll sit there and put the node into a power save mode, which helps as well.
That's just a little. That's actually we do in our Slurm prologue and epilogue.
Yeah, that's true. But after the RCX on Grace, I'll throw it into a power save mode till it's ready to accept jobs.
Right. So anyway, just wanted to jump in and make sure that they understood it. That's not our provisioning tool. That's our little script that actually checks the health of the system.
True.
And this is we're also huge fans of adding these checks into Slurm epilogue as well. There is some things that can happen on your nodes that degrade them and they won't perform as well as they would. And one of our goals is to ensure that every node is healthy before a job schedules on it. So we have added some stream checks in our epilogue that takes like 2 seconds to run just to make sure the stream bandwidth is okay on the nodes and make sure it's performing okay. So little things like these ensure that the users get consistent performance. Although in cloud environments, I don't think they care anymore. We care as of course computing.
Exactly.
We want to make sure the systems are running effectively and efficiently and users don't complain. But anyway, All right, any questions on
Yeah, let's move forward.
provisioning or,
There you go. Questions or comments? Alex,
I did not
oh, I thought you did. I saw you go like this. But I do want to, Tommy is right where that is not the actual provisioning system, but for me, from my point of view, the way I look at it is once the system has been imaged, it's returning it to making it ready for a compute service is like the final step of saying, okay, hey, this node's provisioned, send it out.
there is also one other aspect. I do want to encourage folks who are working on the OpenCHAMI to think about it. It's also the testing of the cluster after you're done with provisioning. You know, we spend probably about an hour at the end of our maintenance because we've taken everything down and pushed out updates, where we just run a whole suite of tools and jobs, just regular job scripts that users normally run across the board on every node we can, just to ensure everything's performing consistently and everything's healthy on your system. You know, it's worth the time and effort to do that during maintenance. Obviously, you're not gonna do it every day, but just something that to keep in mind. And the other thing is I want to also make sure to add is something that we started tracking again with tools locally, and I think OpenCHAMI may have provisions for this, but track the node history on a node. We've had cases, we call them the lemon law, basically, where the node has failed 3 times in the same exact manner. and it's like, look, guys, we've replaced the components you told us to replace, but it's failed 3 times this exact same way. Just replace the damn node. So anyway, we found that's very helpful. We're like these subtle little problems that, you know, persist over time. It's like, well, that node had this a year ago. Why is it happening again? So, but
Yeah, I mean, he's right. Just to give you an idea, because of this tool that we use to track that, there was a budget question about, hey, should we pay this much money for renewal for a specific piece of hardware? And over the last year, only 3 pieces of that hardware had to be replaced. So we saved ourselves double-digit thousands of dollars by just saying it's only 3, not a big deal in the grand scheme of things. So yeah, that's a great idea.
I guess I just hadn't thought of my question yet, but we all knew it was coming. So as you're talking about the RCS stuff, honestly, that was the most interesting to me. I mean, all this is very interesting, but that was the most interesting thing to me. And then you came up and highlighted it, that it's the continuous testing.
Mm.
And this is an area where OpenCHAMI scope questions come in, because one of the things that we've been doing at Atlanta is saying, we'll get you the hardware, but then we want to put the workload manager in charge of doing those continuous tests rather than having it part of OpenCHAMI. But you're not the first person to say, how dare you hand off a node that you aren't sure is ready, right?
Let that node start a job until you ensure it's healthy. And,
Right.
Otherwise, you get users just complaining. Yeah.
Yeah.
So, and you know, one bad node will just eat your whole queue of jobs if it's like failing every job. So,
Yep, that's right.
So thinking about scope for OpenCHAMI, like how do we, like, this is a good question. Like, how do we balance not handing off a bad node and also like keeping the scope of OpenCHAMI narrow as well? So
I'm just gonna say, this goes in that column.
on the right side.
Where it's like OpenCHAMI is, you know, this is what OpenCHAMI's core function is. And then there's the.
So in your presentation, you had a column of what OpenCHAMI does and things that are already done by something else that does it better. RCS, I think, should be in that other column, and it should just be a tool that you can pull into OpenCHAMI. When you're doing your boot up, it's like, okay, now I finished and hand it off to RCS to do what it needs to do. I mean, it's very similar to the node health check from Lawrence Livermore. We have our own sanity check.
Yeah.
I think this is actually better because very few of them actually do any kind of benchmarking already. So that to me says, hey, I want that.
We every node in there before it goes back into production runs at least a stream and an HPL. And normally we will run an MPI job on it as well, because we've also had cases of where MPI tasks won't all launch at one time and you don't catch it when you just run stream or linpack. So yeah, it's
In the case of GPUs, you might want to check the memory too, you know?
There's the Babel stream. So you can run Babel stream, and it's a fairly good benchmark for
Okay.
GPUs to make sure your memory on your GPU is working at speed.
At what it should be, right? This is always the thing,
Yeah.
ensuring it's performing as they expect. And when you have the degradation, that's really when they, now, whether it belongs in OpenCHAMI or not, I do have one of our rules here is the system administrator is actually ensuring the nodes are performing and they're healthy. So that is part of their role. So it's not for the HPC group or from other groups. And so we kind of combine a lot of roles here because we're small and academic and
So it's good.
yeah. So
We'll run this over.
Relay.
I think it's really important. I mean, to keep OpenCHAMI very small, I don't know, right or left. I think what we are hearing here now is our opinions. And so you could have like an OpenCHAMI core. It's really, really very difficult to keep something concise.
mhm.
And
But you always get feature creep or something.
yeah, so I come and Alex, I mean, in my group right now at Bristol, I was telling someone, they called me no as a service. So that says no to it.
NAS.
Job. So, but I mean, I'm not going to read it. However, there is a value in understanding and learning from the community. So I think we could have between yes and a no. I didn't come up with an opinionated view from the community, how to do monitoring, how to do X or Y together with OpenCHAMI. And these could be special interest groups or whatever form we would like it to be. Because I think it requires like a lot of discipline and courage. And I come in not because I let you to do that. No, we do not want to. I mean, we heard this morning, giving a node healthy back to the system, especially when they cost now a lot of, really dense GPUs cost a lot, and there could be a lot of failure. So we must do it, whether we do it in OpenCHAMI or not. I think that should be left in an open way, because some sites may choose to return the node very quickly for all sorts of programmatic, technical, or other reasons, and some sites may not want to. So sorry to take like we all do that. We run like these. If you are an NVIDIA system person, they are like NVIDIA DCGM. I hope at some point they were kind of correctly together. But there are so many ways to establish health check before or after jobs. And I think our community has been, as it was said, doing this thing for decades, if not longer. So that would be my opinion.
Yes, the organization remains still young and governance stuff is decided on, I think, partway between day 2 and day 3. I think it's probably safe to say, although maybe I'll get a Linux Foundation lawyer coming after me for this. Something may not necessarily be included in OpenCHAMI, but they're probably we're not going to stop you from saying hey, we've integrated this with our OpenCHAMI managed system. Here's how we did it. And then, we can have a discussion around, do we want to upstream this as a fully supported product that works for all possible installations?
I think that's an excellent point. We've gone way off topic of your stuff. I would like to return it back to you, but I also want to highlight that's exactly what Dell was talking about this morning, is the portions of Omnia that you feel are most, appropriate to remain in Omnia, those stay in Omnia. You do this your way. There are parts that will be part of the community. And I think all of us are going to be doing something similar. The stuff that we think is core, we're going to be contributing. The stuff we aren't ready to share, or we don't think is core, or we think it's special for our site, we'll be keeping those things. But I'm looking at where we draw the boundaries, how we define modularity. And yes, we need more no as a service. I completely agree.
No as a service.
So back to you guys, and we'll keep wandering around with the microphones for you.
Oh, perfect. All right. So Cobbler was mentioned earlier, and Cobbler basically is like a suite of tools, as I see it, that help you manage system deployment. If anybody's ever used Foreman before, it's like Foreman without all the headaches and the hassle. It's just one package you install. You pull in DHCP if you need to, TFTP. Whereas with Foreman, you're configuring a lot of files, you're checking groups, permissions. It's definitely a pain in the butt. So what's really cool about it is it'll help you manage, like I said, DHCP, which means it'll put the entries into dhcp.com for you. It'll even restart the servers if you needed to. TFTP, it'll actually create grub config files for you to boot over the network. It can even help you manage DNS, including reverse records. So there really is a lot that it offers for such a simple tool. And this could be a good or a bad part. The primary configuration file for it is just a YAML file. So you can open it up, look at it. It's well commented. Yeah, the learning curve is not too steep for that at all. Another thing it can do too is when you install Cobbler and pull in a distribution, it'll help you manage the repositories. So you can tell it, hey, I want this EPEL repository mirrored, and it'll pull it down for you locally. So what will happen is that once it's pulled down locally, that can kind of be pushed out to your compute node. So it just contacts the machine with Cobbler on it versus like having to go out and download the packages remotely. I've been bit in the ass before where EPEL has updated the repositories and a specific package that I needed is no longer there. So the idea of Cobbler downloading and keeping it local is definitely a great feature. So we have some primary terminology here. Distro is actually distro distribution, whether that's Rocky 3, or Rocky 9.7, RHEL 9.3, so on and so forth. Repository, everybody should know what a repository is. Profile. The profile is basically like the meat and potatoes of a system. Profile will have the repositories configured with it, the distribution, architecture, so on and so forth. And then the final piece is system, and that's basically what they call a compute node or a node. So really the important part here is that we want a MAC address and an IP address, and basically the host name. That's kind of what you need to get going. What we like to do is there is a command called import, and what import will do is basically pull in everything for you. It creates a distribution, creates the profile, and creates the local repository for you. So it's kind of like the one command that does everything. So these are kind of just some screenshots, a little bit of eye candy. So right here, I'm just showing you what some of the options are for the distro command. You can see the name, what it's been assigned, architecture. The bootloader will come from the profile. So it shows you that's why it's inherited, means it's coming from somewhere else. OS version, where these files for NetBoot are stored at. It's pretty self-explanatory. Profile is a little bit more, so I kind of had to like make the screenshot a little bit smaller. But you can see some of the data here, like the bootloader, which was inherited in the distro. There's grub, so it creates all that for you. We can assign name servers, the path, so on and so forth, the repos that are part of it. So again, what's great is when you add a system and assign it to a specific profile, it'll grab all of this information and include it. Repository, we can kind of tell where we're downloading everything and storing it. And what's kind of cool about the repository here is that if you don't want to download locally, you can tell Cobbler this is remote only. And so when it writes out a repo file for you, the compute node will know, oh, hey, I have to go off the network to grab this. And then the final one here is system. Kind of just, again, not showing you everything that's available, just kind of giving you the first couple lines here. So we can see right here, a gateway that's been assigned, the host name, name server path, kernel options, so on and so forth. And then if we were to add a system by hand, this is kind of what we're looking at. So I took the liberty here and kind of mixed some of the host names here. That system actually doesn't belong to Vista. It's an old DPU test node, but you kind of get the idea of what needs to be done here. Interface type really isn't important. It doesn't matter. You just need to give it an IP address and all that information. Okay, now we're going to talk about LOSIF. So a caveat, today I didn't know it stood for Linux Open Server Framework. So that's news to me. It's kind of awesome. Basically, LOSIF is a suite of Perl scripts that will manage the system for you. So obviously, like the bullet points here, we need to manage configuration files. We need to manage packages, whether those are OS or custom. And also we need to provision nodes. And in this sense, provision nodes means let's bring it in sync with what it should be doing in the cluster. One of the primary words here is the role. The role is what it's going to do. We like to call login nodes login role, compute nodes a compute role. It can basically be anything, but think of it as almost like a host group or an appliance type, anything that you're going to add a collection of nodes to. So think about like a login versus compute role. You might actually have firewall rules on a login node versus a compute node. So you want to just pay attention to that when you're adding content to the roles. And what was great is that LOSIF was developed to integrate with Cobbler. So instead of doing that manual system add that we saw in the previous step, you can tell LOSIF to basically add the node, which makes it a lot easier. And it's just a flat text file. So that's great. Nobody wants to deal with anything but text. And since they're pro modules for dependencies, I consider that lightweight. Again, going back to Foreman, that required Ruby and tons of Ruby gems. And to me, that felt a little brittle because if one of those gems was updated, it could introduce breaking changes. And I've broke Foreman several times and I've had to downgrade and just basically make sure that that system never gets touched, which could be bad for obvious reasons. So the quick configuration. Basically what this is that we have a set of files that you need to make sure are present and configured at a bare minimum. And they are basically key and value pairs. So text file, key value pairs, very, very simple. We have our config.machines file, which basically contains a list of the roles and the machines that are going to be associated with that role. The config.cluster file, obviously cluster can be changed to whatever the system name is. So Vista's example would be config.vista. And that contains a bunch of stanzas that will dictate what are the config files, what services, what the profile is, which is associated with Cobbler, what kernel options are present, which is associated with Cobbler. Once we look at the file, there's tons of things you could see. Like there's even services you can tell it to be on or off. And then we have the two packages files, one for OS packages and one for custom packages. And then the last file is the actual file that you'll use to basically feed into Cobbler. So once that file has been created, when you add a node, LOSIF will do its magic and basically wrap the Cobbler system add command and then just provision the node for you or get it ready for provisioning. So file synchronization, these are where the roles are actually going to be created right here. So you can see in this login directory, that is a role. So all of the login nodes are going to be matched against that role. Oh, let me go back. Oops. So you can see the files that we have here. We have SSH keys. We have our filter option script, a Lustre configuration file. And then on the other side, we can actually see the actual role directories themselves. So we have a batch role, which is going to be for, our Slurm controller. Common, which is just basically consider it like a directory that contains all files that are going to be common to the cluster. That's typically not a role itself. So just putting files in there, you can actually symlink. Like let's say there's a roots SSH key. You can put that in common and symlink that to every other directory. That way that root SSH key gets pushed out. And then here are the CLI tools. So LOSIF is the primary tool. That has a bunch of options. So you can say LOSIF add RPM if you wanted to add a package. LOSIF add package if you wanted to add a OS package. Update. Update will not only synchronize files, but it'll also pull in any package changes. So whether that's removing packages, adding new packages, or upgrading packages, update will do that. And again, update your configuration files. So sometimes you don't want to update packages. You just want to sync configuration files. So that's what that sync config files will do. You can either supply one argument, which is the name of a file, like its actual path, and it'll synchronize it. Or if you just supply no arguments, it'll sync every configuration file, which is excellent. Node types is basically like a sanity checker tool. You can run that directly on a node and it'll tell you, oh, hey, this is what I think my role is. So you can do some checks here to make sure, hey, is my syntax correct for our config.machines file. And then CUMI_CF. At first, I was kind of a hater of this command because it was basically like an SSH wrapper, and I preferred PD shell. But CUMI will allow you to have up to 1,024 simultaneous SSH processes running, whereas with PD shell, my fan out caps out at 256. So if I want to get things done, I'll run CUMI. The only bad thing about that is you don't actually have like an interactive shell or like a little terminal or whatnot. You just have to run it all in one swoop, and that's it. So here's some eye candy. So that's just adding this package right here. So you can kind of see the output. It tells you what it's going to do. And then it goes ahead and adds it to the OS configuration packages file. So we can add a custom RPM this way as well. And what's kind of cool is that a lot of the arguments you can provide to the actual RPM command, you can kind of provide to the LOSIF command as well. So relocations, the alias, which is like, hey, we want it to go only to a certain subset of nodes. You just provide it to the path of the actual RPM. LOSIF will save a copy of it, and then it'll add it to the manifest for these custom RPMs. So one thing that could kind of stink about this is that you'd have to do one package at a time. So for those that are initiated, you could just put that in a for loop and add a bunch of packages at once, or you could do it one at a time. So that's really just one of the negatives. And then here's the node part. So again, instead of running that entire cobbler command where I'm adding a system, we can just tell LOSIF to either insert a node or add a node, or you could reinsert. And reinsert is typically when, let's say we've replaced like the motherboard and like the MAC address might be different. Once we've updated that in our ips.cluster configuration file, we just tell LOSIF, hey, re-add this. And you can see what it does right here. These provisioning settings are kind of important because those are actually part of the config.cluster file. So those are more towards the end of the file, and that is where the cobbler integration is. And I'd like to point out that you don't need to run cobbler to take advantage of LOSIF. You can still use it for a generic, general configuration management system. It's like if you want to sync files and things like that. But the whole LOSIF and cobbler stack works pretty darn well. And so right here, I'm kind of just trying to give you an idea of what some of these configuration files will look like. So for the config.machines right here, underneath here would be like a role name. So it could be like, let's say it's login, and it would equal login, and then like whatever those hosts are. So like, let's say you have head node 0 through 5. You could do login equals head node and then bracket 0 through 5. So it takes almost like the hostless expression that you would see in Slurm or through PD shell. The config.cluster file right here kind of gives you an idea of what's going to happen. So the config files right here is basically saying, hey, these are files that LOSIF is known to track and will synchronize. So like etc banner, etc hosts, you'll want to put those in there. And then the ips.cluster file, again, will look like this. So we have an IP address, the known MAC address, the interface name, and then a subnet mask that we supply. And that all gets fed into cobbler when we add a node. Here's what the package manifests look like. So again, it's a key value pair. LOSIF will track the package through an MD5 sum. And the reason why that's important is sometimes our HPC group will give us new packages to install, but sometimes they don't actually update the release version. And what will happen is when you go to add it, LOSIF will be like, oh, wait, this doesn't match. So it's kind of nice to have that sanity check in there just to make sure you're not installing a package over another package. Right here, it supports the notion of aliases. So let's say we want to add a bunch of different packages to a specific alias. So like one that comes to mind could be the Mellanox OFED. We know that that takes like, roughly 20 to 30 different packages. So what we'll do is we'll just create an alias like right here where it says Mellanox OFED, and then all these packages get added to it. And then we would assign these packages, or I'm sorry, the alias to a role name. So again, it's just text. It can be a little mundane to manage at first, but once you start doing it after a while, it starts to make sense and it can be a breeze. And then in the OS packages config, it's a little bit different. It kind of just gives you the role name and then what the packages it gets installed. So like obviously the version, the release, and the architecture. And this is really cool. This is the actual command that we would run if we were going to update. So again, update not only syncs configuration files, it'll also sync all the package changes. And that -Q at the end kind of just makes it quiet. Like I don't want to see everything that gets synced over. I just really want to see the package activity. And right here, you can see I've added some packages that are getting installed. And then at the end right here, we have a nice little status line that tells you what gets done. So 2 custom packages were added out of 398 that are being tracked. No files were updated, no links were updated, no services, no permissions. And at the end, it tells you what its role is or what the role of that node is supposed to be. So again, it's also like another sanity check. So pros and cons, I'll kind of just, rant a little bit here. Again, the learning curve is minimal. When I started at USF, they had Puppet and Foreman, and learning Puppet at first, it wasn't, hard or difficult, but it was just like, oh, there seemed to be a lot of gotchas, a lot of trial and error just to make sure I understood. And that was just basic operations. No real dependencies. So again, I mentioned earlier, it's just pro modules that get pulled down. Those aren't probably going to be changed anytime soon. So that's great to know. You can have push and pull options. And what I mean by this is that normally we do a push. We'll initiate from our head node, hey, update the nodes right now. You could also put it as a cron job if you wanted to, but I wouldn't recommend that. It's kind of nice knowing that when you've made a change, you can go ahead and push them out versus like a node saying, oh, hey, some change was made and I pulled it when there was a mistake. So it's kind of nice, just having those 2 options. But personally, I prefer the pushing option. Configuration file, again, is text-based. It's real simple to understand. Comments are supported. Minimal number of configuration files. So like I said, we have the config.cluster, we have the config.machines, and we have the IPs.cluster. So at a bare minimum, just 3 configuration files. Obviously with the packages, you now have 5. But again, once you get into the workflow, it's real easy to understand. You can make changes to the source code. So to give you an example, the Grace nodes that we have don't have any Ethernet cards on them. They're InfiniBand only. So I wanted to make it a way to where I went and provisioned these machines. I wouldn't have to sit there and, do it by hand or do it in a for loop. So I just edited the code, put in a string that said IB only. And so when I added the node through LOSIF, it knew to add its IP address, it knew to add the MAC address, and knew to add to the primary interface, which is the IB0. And that was all put into the kernel option. So when the machine booted, it didn't have to have the IB DHCP, which is a longer address. It just needed what the flex boot reported, and that was it. It only needs to be installed on a single node. So that's great as well. So with Puppet, you have to install that on every node. You can't just have it on one machine. And we just share it over NFS. So great. It's one machine, NFS mount, we're good to go. The package configuration. So when you add new packages, it'll actually keep a copy of the previous file. That way, if you've added something in error, you can quickly look at the previous manifest and undo your changes. And then obviously specific hosts can be targeted in any role by adding a host name. So let's say you have a set of login nodes, but then you have a special login node that only allows certain people. You could call a file access.conf.login5, for example, and only that will be applied to the host that's actually called login5. So it gives you a little bit of customization without having to create like a completely separate role. So cons. Adding additional roles can be kind of a time-consuming process, which could be error-prone. Because what we have to do is when we create a new role, we obviously want to copy files into that role, symlink if necessary. What I thought about this is like just having like a generic like role directory, if you will, that whenever you create a new role, that gets copied and renamed. So the problem is with it being multiple text files, you want to make sure that those get updated as well. So it can be a little time consuming, like I said, and you can't introduce errors because you're doing it manually. The installation has to be shared over NFS. So that means obviously if the NFS server is having problems, we've all been there. You have a machine with a network file system. Let's say that network file system goes offline. You're going to see some issues on your node till it eventually times out. So, pro and con. Really advanced features such as templating. So I don't know if anyone's ever used Puppet ERB syntax, or I think in Python it's Ninja or something like that. That does lack. So you really don't have a lot of templating options. You kind of have to be direct with what you want to do. I do appreciate KISS being in there, but like sometimes it would be nice to be able to play around with some templating. One of the things I've been thinking about too is when LOSIF does run, if a file gets overwrote, it will save that previous copy in your temp directory. The problem is it only saves one copy of that before it overwrites. So there is no real source control, and also it's in temp. If the machine reboots, it's possible that those contents could go bye-bye. So, if there were some built-in source control that allow you to have multiple copies of that file, that would be great. But again, it's not really that big of a deal. One of the things that bit me was a duplicate file name. So let's look at let's say ldap.conf. If you have OpenLDAP, you're going to have etc OpenLDAP, ldap.conf. If you're going to have let's say NSCD, you might be, or NSLCD, you might also use etc ldap.conf. You can't have a file name, two of the same files named in one single directory. It's just not going to happen. So in order to get around that, you'd actually have to symlink the file. So let's say you have OpenLDAP underscore ldap.conf, and then you'd have, let's say, NSLCD underscore ldap.conf. You'd have to edit the configuration file and put the file in there, like the actual path to it in the configuration directive, and then you'd have to symlink it as well. Not really that big of a deal, but it's kind of nice with Puppet. You could sit there and have a file, call it whatever you want, and you're telling Puppet, hey, the source of this file is actually here. So that kind of negates that issue. And then the last one, which bites me all the time, is LOSIF versus LSOF. Sometimes we mistype, and you don't want to run that LSOF in parallel. That could not be fun. But that's really it. Obviously, OpenCHAMI seems to have a lot of things that address that are addressed over what LOSIF and Cobbler can do. But in terms of being simple and effective and it works, it's definitely a great tool. So I guess any questions, comments? All right then.
Had questions? Okay, this is working. Go ahead.
Hi, thank you very much for that. I used Cobbler in the past in a previous life. We used Cobbler and Ansible together. I'm just wondering, did you ever look at Ansible at all?
I've seen Ansible, but I was like, I'm using Puppet. And then when I transferred here, it's like, okay, what's this LOSIF tool? I mean, I've only heard some of the horror stories with Ansible, like, people removing entire root directories and things like that. But I mean, it seems to be a pretty good, pretty well-known tool. And obviously it has, I believe, Red Hat support.
I did assume that was probably timing. Well,
Keep in mind, all of those have to be in Perl. It's great in time, but I've been doing it now.
So I mostly saw DNF and Yum. Do you deploy any other operating system?
No, so like LOSIF, it actually is, there's wrappers around the DNF command or Yum command if it's pulling in OS packages. And if it's custom packages that we get from our HPC group, it just wraps around the RPM command. So that could be an issue with Debian based installs, for example. Like you can't mess with .deb files. It's not going to happen. This would purely be like a Red Hat derivative that you'd have to use.
And OpenCHAMI, is it open to can you install any OS, or is it tied to?
OpenCHAMI does not have any part in what your OS image is. So it's a different architecture where we think the system image is something that you build and then you bake and you put it through CI and then you boot that on the node. And so there's no concept of then going through and doing package installs and repos and things.
Yeah.
I was struck that the command you use to create a node in Cobbler is not that different than the command we use in OpenCHAMI to add something to the inventory. It's different, like you couldn't just kind of go from one to the other, but they're not that different.
Yeah.
Well, we also have a modular concept.
The goal or the concept also is that everything is somewhat modular. We can replace pieces of the packaging. In fact,
Yep.
At one point cobbler broke and we were going to replace just the cobbler piece, but yeah, we could remove. In fact, the tool was originally developed by removing bits and pieces out of the old impacky rocks. If y'all have been around clusters for a long time, where they went way overboard on a lot of their packaging and everything. And it's overkill. And so we started just ripping pieces out of it, and finally we just wrote everything ourselves. And
So again, I mean, if you do know how to read Perl and edit it, you can get around some of its limitations. So initially, I found an issue with it where I could add an RPM that was based upon the AAR64 architecture, but if I want to remove it, that function, that part of the code was never present, so it would error out on me. So I had to go in there and make an edit, and then after that, I was able to remove, AAR64 RPMs. So
Designed for that level.
but I'm just saying that, like, it's text, like Perl's text language. You can sit there and edit it if you need to. So it's kind of nice that the torch can be handed to different people to make, different changes to the system.
So before we let you go, so Tommy, I think everyone here knows Tommy Minyard, who wrote a lot of this. Yeah.
Yeah.
So forgive me, I thought you'd retired. Did you come back just for this?
Officially retired. I come back part-time to help with their Horizon deployment. So trying to make sure these guys are doing the right thing.
We're very glad to have you. It's a celebrity in the midst.
I'm officially back on the payroll at halftime. So yeah.
So as I'm looking through this, I'm seeing design decisions that would have made it, well, so I was designing system management at the same time when this was written, and some of those design decisions look like totally the things I was doing at the same time. Are there things that you guys have been learning about OpenCHAMI that you're like, you know what, if I were going to do it today, I like that idea better than what I'm doing, what we've got in here?
I haven't got enough into it yet, so I'll have to admit I'm maybe John sees.
Well, so like one thing you mentioned was how the UDP maxed out at like 256, I believe. So it was kind of cool seeing how you were working on trying to get an basically like a node, if you will, that had multiple interfaces to kind of address that limitation.
I think I was talking about that yesterday. I don't think I was talking about that with.
But that's going to be part of
that's
going to be part of OpenCHAMI, though, right?
Yeah, so John and I were talking yesterday about how one of the challenges of scaling DHCP on a large cluster is that UDP is not a wonderful protocol for making sure that a packet gets where you want it to go. And so if you get above a certain level, given good switches and whatever, you're going to lose UDP packets. And so one of the options you can try to do is you can try to max that out, get as many of them as you can, or you just run DHCP services on more interfaces. And that's what we're looking at for OpenCHAMI, is rather than running, 10 physical nodes that are running DHCP, we're one node, but with lots of interfaces. And we think that's going to give us some scalability. Yeah. We'll test it out.
I mean,
math works. Let's find out if the
exactly
software works.
I mean, so like just to highlight that, I got bit in the ass because once I had a working process, I'm like, I'm going to provision 5 racks at a time. So as I'm waiting for the nodes to finish, I'm like running uptime up. I'm like, why are these nodes not responding? And I walk over, I'm like, oh, they never got the advertisement. So it's like, oh man, it would have been better just to do maybe 2 racks at a time and not be so, John Wayne about it. But I think everybody here probably thinks the same. Once you have a working process, put that in a loop and let's just knock it all out at once.
Yeah, what do you mean scale? It worked on my machine. It's fine. All right. There are other questions. Yeah, Garuma.
In all of what you've described, like, how do you handle the container piece on top of the VM and stuff?
There are no containers here.
So
To handle the container side, we actually, that's one of the HPC groups. So this is the ones that kicked it over to the right hand side of that graph. Containers are the applications guys' responsibilities. We will install the base stuff. So we have Apptainer, we have Charlie Cloud. I think we haven't done Podman yet, or
No, I believe it's just the Apptainer.
no. So right now, Apptainer is our primary one. That seems to be what most of our academic users are going to use. We do have Charlie Cloud. We have a couple of people using Charlie Cloud as well. So, but yeah, we let them handle the containers. We'll install the base configuration stuff and but it's up to them to handle the container side. Which is a challenge because a lot of people don't actually have root somewhere where they can make their own containers.
Yep.
Something we kind of, neglect to, remember all the time. And so we've had the right wrappers and tools to actually convert containers to run on our systems. So.
Okay, are there any questions in the room? And then I couldn't tell, there might have been some questions online.
Yeah, let's check real quick.
Oh, there's 3 chat questions.
There we go. Jinja, yeah, thanks, David. Yeah, Jinja. I don't know why I thought Ninja. All right, let's see.
Node health check. This is from our node health check discussions.
So with node health check, I would suggest you consider is the resolution of this issue from OpenCHAMI. Everybody can read.
See, Adam already responded. So.
Okay.
All right.
Yeah, so it looks like that was it for the lack of questions.
I think this is working. Yeah, there we go. Okay, so thank you very much.